I just wanted to shoot one more video. Hey, this is a thing I came up with a while back when I had an interview with Ruby Tuesdays. So this is called Paul's Attempt at Game Theory. Oh boy. So here we go. Here's the scenario I came up with. A certain restaurant wants to attract more customers, and by doing so it wants its employees to dress in an attire that will attract more customers. Aside from other tactics or entertainment ideas to draw people in, it wants the guys to dress like a chicken and the girls or women to wear less clothing. Damn. Even though it borders on sexism, the restaurant believes this will increase in sales or do well for business. The question is, how many guys would be willing to dress in a stuffy chicken outfit to attract more customers without quitting? And how far would the restaurant and waitresses, female servers, go to draw in more customers and therefore increase in sales? Or at what point of compromise or negotiation would have to be made so that all three parties will be satisfied? And here's the formula I came up with this. This is just the chart. So we have let L equal loss, let G equal gain, and let N equal random between 21 employees. I didn't have really a time to put all that, and plus it's hard to write with this touchpad thing. Touchpad thing kind of sucks. So we have -2, and on the right side we have 2, and on the bottom we have -1 and 1. So the formula is function or f of parentheses L and G equals 3L standing for loss plus 2G standing for gain plus N, random amount of the 21 employees that work there. So here's the setup for this. You have 3 parentheses, this is supposed to be a question mark, plus 2 parentheses question mark plus N equals question mark. So if you plug in these numbers, the setup is f of f in parentheses standing for function of L and G equals what I just said, and then so you start plugging in those numbers. 3 times here we have -2 and 2, so it would be 3 times -2 plus 2 times 2 plus 1. This is for the guys that take one loss. Sorry, for the top, this stands for guys, and on the bottom it stands for the women. I know this is not traditionally how you normally look at game theory, but so we have -6 plus 4 plus 1 equals -1 guys take 1 loss. And then the formula for the women would be f of parentheses -1 and 1, substituting, plugging in those numbers for L and G. Here for 3 equals 3 times, in parentheses, or times -1 plus 2 in parentheses, or times 1 plus 1 equals -3 plus 2 plus 1. So the girls take 0 loss. So if we do and for the next chart, we change these numbers, the formula or the gain and the losses start to change. So for the next one we have -2, we'll change this to a 4, -2 and 4, and change this to a 3, erase, and back to this, and change this to a 3. It starts to change. So then if you plug in those numbers, you get a 3 gain for support and a 4 gain that don't support. So the supporters of the women wearing less clothing and the guys dressing in a chicken outfit varies upon the amount of voters. Turn that off. Man, I'm all dry and boring today. So, but anyway, that's the thing for that, and these chart starts to change as you go down, and then the conclusion of it would be 7 out of 8 guys and girls, and 11 out of 12 support and don't support. So 7 guys agree and 8 girls agree, and 11 customers agree and 12 don't agree of the idea. for the restaurant. So so that's that for that, and God bless all the countries except for the ones ran by Satan. Just kidding. All right, bye.